The dream of intergalactic travel, of venturing beyond our solar system and touching the stars of distant galaxies, has fascinated humanity for centuries. For generations, it's lived in the realm of science fiction, fueling our imaginations but feeling forever out of reach. But here's the thing about us humans, we have a knack for turning the impossible into the possible. As technology advances at an exponential rate, what once seemed like science fiction is inching closer to reality. But how will we bridge the unimaginable gulfs between galaxies? With the latest breakthroughs in intergalactic travel technology, the answer may be closer than we think. Let's dive into warp drive, the holy grail of space travel. The universe has a speed limit, the speed of light. Einstein taught us nothing can travel faster than light. But what if we could bend space-time itself? That's the concept behind warp drive. Imagine folding space-time to bring 2 points closer. A warp bubble compresses space in front and expands it behind. The ship rides a wave in space-time, sidestepping the speed limit. NASA's Alcubierre drive concept explores this idea. It requires exotic matter with negative mass energy density. We hadn't observed gravitational waves when Einstein predicted them. Considering faster-than-light travel is mind-blowing. Now, if bending space-time sounds a little too out there, how about taking a shortcut? I'm talking about wormholes, those theoretical tunnels through the very fabric of space-time. Einstein's theory suggests these cosmic shortcuts might exist, connecting distant points in the universe. Picture it, step into a wormhole on one side of the galaxy, and boom, you emerge light years away. But wormholes are notoriously unstable. They collapse faster than you can say quantum singularity, and finding them is another challenge. Physicists believe they could exist at the quantum level, popping in and out of existence. The challenge is stabilizing these doorways and scaling them up for spacecraft. If we could, it would be the ultimate express lane across the cosmos. Let's talk fuel. Conventional rocket fuel is, well, conventional. To truly conquer the vast distances between galaxies, we need something a bit more potent. Enter antimatter. Now, antimatter is like the mirror image of matter. For every particle of matter, there's an antiparticle with the same mass but opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy. And we're not talking about a small spark here. We're talking about an energy release that makes nuclear reactions look like a damp squib. A single gram of antimatter could produce as much energy as the atomic bomb dropped on Hiroshima. Imagine harnessing that power for propulsion. Antimatter engines could, theoretically, propel spacecraft to speeds approaching the speed of light. The catch? Producing and storing antimatter is a monumental challenge. It's incredibly expensive to create and notoriously difficult to contain. But hey, challenges are what we humans are all about, right? Chapter 4. Solar sails riding the cosmic winds. Sometimes the simplest solutions are the most elegant. Take solar sails, for example. Imagine a spacecraft propelled by nothing more than the gentle pressure of sunlight. That's the basic idea behind solar sails. These massive reflective sails would capture the momentum of photons from the sun or even powerful lasers, gradually accelerating a spacecraft to incredible speeds. The beauty of solar sails is their fuel efficiency. Once deployed, they require no propellant, making them ideal for long-duration missions across vast cosmic distances. Now, the pressure exerted by sunlight is minuscule, so solar sails would need to be enormous, perhaps spanning kilometers to generate significant thrust. But advances in materials science are leading to lighter and more reflective materials, making this technology increasingly feasible. Imagine a fleet of solar sails gliding gracefully through the cosmos, powered by the very stars themselves. It's a beautiful vision of the future of space travel. Chapter 5. Fusion-powered spacecraft igniting the stars. Alright, let's talk about the ultimate power source. Fusion, the very process that makes the stars shine. Fusion involves fusing together light atomic nuclei, such as hydrogen isotopes, to release an immense amount of energy. It's the most efficient energy source we know of, far more powerful than any chemical reaction. Now imagine harnessing that power for space travel. Fusion-powered spacecraft could, theoretically, provide near-limitless energy, allowing us to reach other star systems within human lifetimes. We've already made significant strides in fusion research here on Earth, with experimental reactors inching closer to achieving sustained fusion reactions. The challenges lie in miniaturizing this technology and developing robust containment systems capable of withstanding the extreme temperatures and pressures involved in fusion reactions. But if we crack the code on fusion power, the possibilities for space exploration are truly limitless. Chapter 6. Cryogenic Sleep, the long nap to the stars. Interstellar travel takes time. Cryosleep bridges the gap between human lifespans and vast distances. It slows down metabolic processes, putting the body in hibernation. This reduces the need for resources and minimizes psychological toll. Imagine waking up decades later on a new world. Researchers are making progress, but we're still far from safe, long-term cryosleep. Chapter 7. AI-piloted starships, the rise of the machine navigators. Intergalactic travel presents a unique set of challenges, requiring complex calculations, split-second decisions, and constant monitoring. Human limitations could become a significant hurdle. But what if we weren't the ones at the helm? That's where artificial intelligence comes in. Imagine AI-piloted starships, capable of navigating the complexities of interstellar space, making real-time course corrections, and even conducting scientific research autonomously. Advanced AI could analyze vast amounts of data, identify potential hazards, and make critical decisions far faster and more efficiently than any human crew. It could even communicate with Earth, relaying data and receiving instructions, even across unimaginable distances. The development of sophisticated AI for space exploration is already well underway. As AI technology continues to advance, it's not difficult to envision a future where AI navigates the cosmos, paving the way for human exploration. If cryosleep proves too challenging, there's another, more audacious option: generation ships. Imagine a colossal, self-sustaining spacecraft, a spacefaring ark, carrying not just a crew, but an entire human community. These massive vessels would be designed for multi-generational journeys, with generations of humans living and dying on board before reaching their destination. It's a profound concept, a testament to human ambition and our innate desire to explore. Generation ships would need to be entirely self-sufficient, capable of producing their own food, recycling waste, and maintaining a habitable environment for centuries. It would be a closed ecosystem, a miniature world hurtling through the vastness of space. The social and psychological implications of such a journey are complex and fascinating to consider. It would be a journey of hope, a gamble on the future of humanity, a testament to our enduring spirit of exploration. What if we could bypass the whole spaceship thing altogether? What if we could travel instantaneously from one point in space to another, like teleporting? Now, it sounds like pure science fiction, but the principles of quantum teleportation are rooted in real science. Quantum teleportation has already been demonstrated on a microscopic scale, transferring information between entangled particles instantaneously, regardless of distance. The key is quantum entanglement, a bizarre phenomenon where two particles become linked even across vast distances. Now, scaling up quantum teleportation to transport macroscopic objects, let alone humans, presents mind-boggling challenges. It would require manipulating the quantum states of every single atom in an object, a task that currently lies beyond our technological capabilities. But if we could somehow crack the code of teleportation, it would revolutionize not just space travel, but our entire understanding of the universe. Alright, let's end with a truly ambitious concept: Dyson Spheres. Imagine a colossal structure, a megastructure, completely enveloping a star, capturing all of its energy output. That's a Dyson Sphere. Conceived by physicist Freeman Dyson, a Dyson Sphere would provide an unimaginable amount of energy, enough to power entire civilizations or, in our case, fuel interstellar voyages on an unprecedented scale. Now, building a Dyson Sphere would be an undertaking of epic proportions, requiring technology and resources far beyond our current capabilities. We're talking about dismantling entire planets for raw materials and manipulating matter on a solar scale. But think about it. A civilization capable of constructing a Dyson Sphere would be a Type 2 civilization on the Kardashev scale, a civilization that has harnessed the power of its star. It's a glimpse into the potential future of humanity, a future where we become masters of not just our planet but our solar system and beyond. As we stand on the precipice of the cosmos, gazing out at the vast expanse of the universe, It's clear that the future of intergalactic travel is a tapestry woven from both scientific ambition and the boundless capacity of the human imagination. While our current technology may limit us to our solar system, the rapid advancements in intergalactic travel technology suggest that within the next few centuries, humanity could begin its first journeys beyond the Milky Way. The dream of exploring other galaxies, of unraveling the mysteries of the universe, is no longer just a fantasy. It's a future waiting to unfold. Are we ready to take the next giant leap into the cosmos? Only time will tell.